Welcome into Weld.com, everyone. Today I'm going to be putting this 45 amp Radnor plasma cutter to the test as I teach you all how to put a straight bevel on freehand with the plasma on the edge of a plate and even inside a circle. Let's cut it. Alright y'all, let's go ahead and cut right into today's content. We're going to be cutting 3 different thicknesses of metal. Some 1/4 inch, some 3/8, and some 1 inch. There are 1,000 ways to skin a bevel, but today we're going to be plasma cutting it. Not only on the edge of the piece of plate, but we're also going to be piercing holes, cutting circles, and beveling the inside of those holes with that plasma cutter. Now that's something that is not easily done with just, say, an angle grinder, because that's probably what I would do for a 1/4 inch piece of steel. Just knock the corner of that plate up, and then we've got our bevel already. As far as the degree, that's going to be the toughest thing that we're going to have to maintain as we cut. Today we're going to be shooting for a 35-degree bevel. Now I've already taken the liberty and taking this 45 amp Radnor plasma cutter and doing some straight cuts on the 1/4 inch, some 3/8, and some 1 inch. Because the very first step to putting a bevel on anything is making sure that each plate is cut and square. We need it to be proper and square on each side. The 1/4 inch and the 3/8, they had some shear sides, pretty much a 90-degree angle, or at least as close as it's gonna be. The 1 inch, on the other hand, I didn't necessarily get the perfect square edge. I kind of started it a little shaggy, so I relined it up, went for a second cut, and still made a little bit of a mess of things. Now I think that had to do everything with my travel speed and not really paying too much attention, so I went ahead and knocked it down with a 3M fiber disc to get it down to something square. Even the little blemish that's left, I didn't want to chase it because I don't want to unsquare anything. Everything has to be square when we're trying to put a bevel on it. Most of the time is because that's how they need to fit, is straight up in a line. In this case, that's how we're going to be able to find this 35-degree bevel. We're actually going to use the square side of this and take a speed square. This is what I like to call a speed square right here. And all we're going to do is use the pivot point that's on the corner here and angle this across the plate until we get to 35 degrees. And then we can make our mark. Now, depending on the thickness of steel, you might notice that that mark is either a little bit closer on the 1/4 inch and a little bit more further back on the 3/8, and even further back on the 1 inch. That measurement's going to change, but you can still use the same technique. What I'm going to end up doing is just using the corner of this, finding that 35 degrees, making my mark on the top, measuring that little distance from the square edge, making 2 more marks across the plate so that I know how far back that bevel will be. That's going to be the back side of my bevel. That's that line that I'm trying to make right there. And that's what I'm going to be paying attention to as I freehand cut this out. And also paying attention to, of course, the kerf. Writing that upside down, I'm sure that's good. The kerf of the plasma is going to be taking up some of this space. I don't want to cross this line so that I get no material loss and the 35-degree bevel that I want. We're also going to be taking that same technique and doing it with the circles too. I digress. Let's set up the plasma. Alright guys, if you've watched any of my plasma content before, you should know the rules. We want a lot of air. Got the compressor hooked up. It's pumping. If you have a smaller compressor, you can operate the same amount of plasma cutting except just shorter amounts of time. You got to make sure it has enough air coming out of it, but it's also dry. So we got the air dryer hooked up to get nice dry air so the consumables will last longer, and we have the right consumables for the process that we're doing. You saw me cutting up this 1/4 inch, 3/8, and 1 inch plate with a drag tip and a fence, just gliding it along, trying to keep this as square as possible. When I go to tip this on its side, I'm not going to be able to get as close as I'd like with a drag tip. Not only that, but I like to see a few more things as I do it. So I'm going to take the drag tip off of this guy. We're going to be using the 45 amp Radnor plasma cutter. And you notice when you change the shield on here, you can kind of check your consumable, your nozzle a little bit, but no error code's going to happen. If you go ahead and loosen this a little bit, you're going to see an error code pop up. That's really common with a lot of plasma cutters. That's just saying that something's going on with these consumables. You don't have them in there properly. Just for funsies, we're going to be switching these nozzles out. Got our swirl ring on properly. We've got our electrode in it. Looks good. Make sure those holes are up, not down, because it'll still fit, but it won't work. And you can screw this back on. That error code's not going to relieve itself until you turn the machine. Oh, this one does. Most of the time you got to kick one on and off again and for that error code to go away. So that's really nice, because that's a pain in the butt. A couple different nozzles. This one has a little bit more of an orifice, a bigger hole on the end. It's just kind of wallered out a little bit more compared to the machine shield that I'm going to put on for all this freehand plasma cutting today. That's what I usually use if I'm going to use freehand stuff. If I'm cutting by hand, I don't always use that drag tip. That's only just for cutting straight lines, in my opinion. For this tip, obviously it's a much bigger hole in the opening and that goes with that gouging nozzle. Let us know if you want to see any more plasma gouging content. I'd be interested to try that out because I've never seen the nozzles that are necessarily dedicated for that. We have 45 amps coming into the machine. That's all the way up on here. We have the mode selected properly, and we've got enough PSI coming out of it. Looks good. Little test fire. Ready to rock and roll. All right, let's get suited up to cut here. I'm gonna go ahead and put my welding cap on because I'm gonna wear a welding hood. This plasma cutting is gonna get bright. It always does, right? It's brighter than a cutting torch. It's not as bright as a welding torch. About shade 6 is gonna give me the right kind of shade that I need so I can see and also stay safe. I don't even need to put that on yet because I need to wear a respirator. Now I'm going to try not to talk through this because I know y'all hate it, but we do want to stay safe. Wearing this respirator is going to help. So we'll have our hood, we'll have our safety glasses, we'll have our came-in gloves on. Want some thicker gloves here. I really like these little short cuffs for this type of stuff. And then we have, of course, all of the plates that we're going to cut. Now my goal is to angle here and cut this edge off. As you notice, I got my mark back all the way. We laid it out with the speed square, as well as punching a hole and using my homemade compass here. This is just a Sharpie. Just tape it up, make a circle, right? Had our piece of pipe. This is the goal to have to stick through here. You'll see there's a little bit of gap around because this is kind of simulating what I would consider a full pin weld that I used to do in the pressure vessel industry. It was more closer to the thickness of this 1-inch plate with some real laid back bevels, which is what we're going to try to do today, is pierce a hole, cut the hole, bevel the hole, along with cutting a straight edge. Cutting a straight edge might be something you want to have a nice smooth guide for. I don't have a fence because getting as close as I can to this edge with that plasma torch is going to be the trick. I might be actually able to use this machine shield since I'm going to be running on its edge itself in order to follow it along. You can also use stuff like little matchbox cars. I think this is a great technique so that you can help slide your hand a little bit better. Just make sure that you have enough room so you don't hit a speed bump and then you put a speed bump in your plate. I'm gonna probably use this as a little bit of a guide, even if you have to stop and feather out right here, reposition and cut it from the other way. You do whatever you have to do in order to get it happen. Doesn't mean that you have to cut it all the way in one swipe. The goal is to take the majority of the meat off because we're probably gonna have to take a grinder and clean it up anyway. Enough talking about it, let's be about it. Let's see what I can mess up here. Ooh, real quick, we wanna lay out our circle too. This was 3/16 back from the square edge, so we're gonna find another 3/16 from our line and make a mark there. 3/16 right there. Now this is including a gap for the actual root pass. Well, I don't think we're gonna get around to welding nothing today, but we do want to lay things out for our bevel so that this is the same amount of distance behind our cut line, our cut square line, and then that's the line that we're going to follow for the back side of our bevel. Well, this isn't the best compass because it's not designed for a Sharpie, but we're going to get pretty close. At least you get the idea. Anyway, let's cut. Just don't let go of that trigger. Okay, let's pierce this hole. Anytime we pierce a hole, we're going to point down and away from us, towards the camera. That's good. It really popped through that one quick. So we're going to try to square cut our circle. Oh, it's shaky. It's very shaky. Oh, what a nasty hole. Courtesy of me. We're just going to go ahead and dive into this bevel. Oh, it's been some years.
like butt.
Now, as far as first impressions go, the plasma cutter did just great. However, I did not. Now, on the straight side, I think that worked out pretty well. You can kind of get a little bit away from the edge, getting more on the line instead of in front of the line towards the very edge of the plate. You'll get a little less dross like I've gotten here, but it's nothing that a little chisel just doesn't just kind of take away. Just gotta flip the stinking plate over. And again, if you've ever watched these plasma cutting videos that we've done in the past, to get a dross-free cut, you really need to focus on your angle, your travel speed, and the distance from the plate. Now, with that machine tip on there, I can, because I've got a little angle on there, I can actually drag it. So that's kind of helpful, but I think especially for the circle portion of it, to get less dross on this material, I'm gonna have to do a little bit more due diligence and just taking off a little bit as I go. Whereas the straight one, I think I can make in one swoop. This circle, I think I got to take it off a quarter at a time, or even maybe even more, because my angle just simply isn't the same all the way around. I would say doing this type of work, you're looking to get close to your line. You're not trying to get on your line, because you're going to do everything in your power to clean things up as far as the inside of a hole goes or the edge of the plate. So let's just go ahead and clean it up and see what it looks like. Hit it with the grinder, see where your low spots are. Just kind of plan it out. Even if you have a blemish or so, if it's not like something that could affect the weld that's going in there, we're still going to be okay. That's something that looks clean, something that I could probably have no issues with. I don't want to chase it. So we're just gonna leave it be. I'll put money on that. That's probably not 35 on the chili, but it's really close to what we need to work with. The next way of getting it in there, especially with a hole like this, is you need one of these cone rocks. This is where you're really gonna focus on getting back to the edge of your line and getting all those high spots out. Now that's going to clean things up. Those rocks are good, not necessarily for removing material, but for cleaning it. I think we got a nice straight bevel here. I think this is still weldable. I wouldn't be super stoked on that gap right there. I mean, gee whiz, that's like, if I'm taking it or making it, we can make it happen, but it doesn't mean I'm going to be stoked about it as the welder. So on this next hole, we're going to try to be a little bit more aware of the gap that we're trying to put in there, because not only do we need to remove the material with the plasma, we're going to even remove even more when we're cleaning it. So we need to be a little bit more self-aware of where we're at. So we're going to take this 1/4 inch, which really wasn't a whole lot of trouble, and let's move on to this 3/8 plate. This was, I think, 5/8 from the edge, excuse me, 5/16. So 5/16. I'm actually going to mark this at 1/4 instead of 5/16, just so I know if I've hit that, I've probably definitely most likely gone too far. Make this circle mark before we get crazy. Back to business. I got a breeze on me now. I got a fan at my back. I'm not going to have the respirator on. Make sure that we have a bit of a push angle as we come into this. I'm going to make it nice and steady. Starting a cut, coming into it. Once we know we got a cut started, we can set our nozzle down and try to find and maintain the travel speed. I want a little bit of a push angle if I can, trying to maintain that push angle as I'm getting closer to myself, dragging that nozzle to maintain the height, trying to maintain the same speed as well. Got a little bit of stuff on the front edge of that cut. It comes off pretty easily. Yeah, that cut worked out good. We didn't even get all the way down to the edge, which is what I really wanted, because again, the goal isn't to get right on the money, but to get really close, a little bit less work with the grinder. This does make quicker work of it. You'll notice that took a lot longer as it splashed up. And you can pre-drill those. You can do other methods of piercing before you go in and plasma cutting, but you can also just plasma cut it. Trying to spend a little bit more quality time with my line here. Don't rush. Drop the pump, and then let's go ahead and put a bevel on it. Once I'm uncomfortable, I'm going to stop, come in from another angle, It's a lot like pipe welding. When you're working in a circle, you gotta constantly be changing that direction, but maintaining all those variables. I don't want to have my torch at a funny angle. I don't know if I can get around this clamp. We're gonna do our best and grind the rest. Yeah, that clamp didn't let me get the angle I want, but we can grind through that. Now at this point, we're definitely saving some time removing metal on the edge of that bevel because we can just clean that up with the grinder. We have a little bit, if you want to call that a land. I didn't cut all the way to the knife edge. I did a little bit on the corner and a little bit less on this side. Those are all things to just look for as you're going through the process. But that's like one of those that we could take a grinder to it now and really get rid of the rest of the dross on the back side. Now the idea of the first hole and the second hole is that the first hole should let it do more like we did on the bevel and don't let it get all the way to that point, because it's getting to that point and it's going to make my hole bigger. That's the OD of the pipe that I want. I don't want my hole to get bigger, but I do want the bevel to get laid back. That being said, it's not as bad, I think, as the 1/4 inch. I had this one little backside next to this clamp that I couldn't get the same angle, but I am missing a lot of that edge, which means that I got the OD of the pipe that I wanted a lot better than the 1/4 inch. It's a little bit snugger of a gap. Mind you, I did want a little gap, but not as bad as that 1/4 inch. And now I can grind everything else into that. Kind of knocking off the schmutz. I can see the line on the back and I can see how much bevel I got left, so I'm going to grind everything to knife edge. All right, let's get to this round business. Let's see here. All right, we're zeroed out here. Let's see what we got on this bevel. 45. Well, I don't know if that's exactly right because I can get a little play in it, but I am nowhere near 35. And it just goes to show you how easy you can get carried away of laying something back. However, if I was the welder that had to weld that, I like the way it looks. Same thing with this hole. It's not as bad as the 1/4 inch. It's a little bit more forgiving for the welder as far as the root opening. I got one little nick in it where I kind of pushed it back, but we cleaned everything up. We still have a nice bevel all the way around for this nozzle to go in. Thicker material is always a little bit more forgiving than thinner materials, say like 1/4 inch. However, when we get into really thick material like this 1 inch plate, you'll really see what this plasma cutter is about. Now remember, the goal here is not necessarily to not grind at all, but so that we don't have to grind as much. Let's hack into this 1 inch and take our sweet time. We might have to take it off bite by bite. Still at 45 amps, just to see how I've been for the rest of everything. Still on grind mode. Go ahead and clean this cut up. Now I know what you're probably thinking, Austin, that's a lot of dross. And you'd be correct, it is a lot of dross. And that's what I'm saying, if you're cutting like right off the corner or something, it usually stacks that dross up pretty bad. But you can usually bust it loose. You can see we didn't even make it all the way down through there as I thought I did. That dross was hiding a little bit of stuff. So we're gonna try to take that little bit more off with the plasma cutter. We're really pushing this 45 amp plasma cutter to its limits here. It's really only rated for about 5/8 material as far as cutting from the edge. As we're trying to put this 35-degree bevel on this 1 inch plate, it's really about 1.25 inches worth of material that we have to remove. That being said, we're still capable of taking off bite by bite by bite to knock out bigger tasks than you thought you were able to accomplish. Having a hard time staying lit because the contact to the top of my nozzle, it's not really feeling the metal there. It doesn't know the metal is there. But if we just kind of keep working it, we can kind of chase it. Let's take the rest off with a grinder. Still didn't quite make it down to that edge, but we removed a little bit more metal. We can handle that with a grinder. Now, depending on what I'm doing, I might would chase these blisters back a little bit more, but we've got the bevel on there. Let's see if we can see anything different comparatively speaking to that last one. 63. I don't think that's right. We're going the wrong direction here with this angle finder. Let me do it like this. Yeah, see now we're closer to 26. We still gotta lean that sucker back more, which makes me want to know if I was right about this one too. What is this? Ah, it wasn't as bad. It was only 40 degrees, not 47 or 50. So, haha! A little bit of a challenge to get through that bevel, especially in one go with that plasma cutter at 45 amps. We're maxing it out. I'm gonna see if we can't make this hole possible or not. I have a feeling we're gonna be here for a minute. At this point, the best way to get through that would probably be to pre-drill your hole. Trying to sit here and pierce through an inch of steel would make a mess of things. Instead, we're gonna do that and make a mess of things. So let's see how long it takes to pierce this 1-inch plate at 45 amps on this plasma cutter. What do I not care about in this little shop? I guess that winder. We're definitely making a mess. I don't know if we're destroying this or not, but keep it going! Yeah, we made it. We're gonna need a new consumable. Ow, it's in my glove. Don't try that at home, kids. Just use a drill. Just because you could doesn't mean you should, right? I will say that is faster than drilling a freaking hole. And I don't have like a mag drill or anything to get through 1-inch plate. I would say a couple more amps and we probably could have pierced it a little quicker and probably caused a little less damage to the torch. That's the biggest thing you got to be worried about, is not only yourself, because you're splashing metal around and the stuff around you, but you can damage your torch a lot easier if you're not paying attention. We got a little burn on it, but a little hand wipe and it looks okay. I haven't even swapped the consumables on this yet. We're gonna see if we can get this first hole knocked out. Nice, slow and steady. Apologies for that. Y'all probably noticed there was no arc shot there. That's because the camera died. You can see we dropped that slug out. All the dross came with the slug, so that was really nice to see. It's not necessarily like the straightest 90-degree cut that I'd like to see when it comes to trying to cut a plasma cut, but we got the hole we want. Trying to go back to what we said at the very beginning was we have to have a square edge in order to have a nice cut. We're going to square up this hole with the grinder a little bit, and then we're going to come back with the plasma and put a bevel in it, or at least get rid of the meat so we don't have to work so hard to clean it up. No one said this was fun. Now, if I'm being 100% honest, I probably would have spent a little bit more time squaring this up. I used to do this in pressure vessels and stuff thicker than this 1-inch plate that we would have to cut holes into and bevel those holes. And everything was held to B31.3 standard as far as ASME B31.3 goes. Everything had to be full pin, everything was visually tested, ultrasonically tested, x-ray, all that good stuff. The only quality control that I have to worry about is you guys in the comment sections of this video. That's gonna be close enough for government work today. I'm gonna go ahead and put a little bit of a bevel on that, see if we can get as close to that bottom edge as we can with the plasma cutter, because I still wanna make a decent bevel for y'all. Just checking out this electrode real quick. See how that nozzle's fair, and the electrode looks just fine. I do want a new nozzle. Not that that one's toast or anything. Here we go. Oh yeah, we're gonna take a little bit off at a time. Take a little bit off. Get it out of the way. Yes, I am aware it currently looks like the pit of despair right now, but remember, we can always take off a little bit more. We want to try to avoid grinding as much as possible, so we're going to use this little by little bits at a time. Trust the process. Just kind of watching that arc, trying to just skim things away. Just a little more. I think that's about all I'm going to be able to reach. Dude, we did our best. Now we got to grind the rest. Get some of that dross out. There it goes. Got a lot more to clean up on this side than anywhere else. I might as well hit it with the plasma. I just gotta rotate it. Oh. Hot piece of metal. All right, that got that side a little closer. Get evened up and get that rock. You can see just how much material I'm removing. Virtually freaking none. I'm gonna be here for a while. If you need a moment, now's the time I recommend going to get a snack, going to your local concessions and getting a little bit of an intermission, because I just gotta keep grinding. We sure made a heck of a mess in here today, all the cutting and grinding we did. I was pretty impressed with this little 45 amp plasma cutter from Radnor. It was able to handle the 1 inch, the 3/8, the 1 inch plate. The 1 inch plate we obviously had to spend a little bit more time on, just taking off a little bit as we go, whereas the 1/4 inch, I think I got a little bit more carried away. It's just so easy to remove that little bit of material compared to the 1 inch. You can kind of take your time a little bit easier. And we've got like almost the perfect foot up for a nozzle to run into that hole, get complete joint penetration and complete fusion all the way out when it comes to, say, welding a nozzle for like a pressure vessel. When it comes to plasma beveling, it's not about not having to grind at all. We're gonna leave a little bit of those oxides on there, so we are gonna go ahead and have to grind. The point is trying to get it as close to your lines and as accurate as possible so that you can grind to the spot and get it right on the money and everything's perfectly prepped and ready to weld. Everything that you've seen in this video today, we have links down in the description below, so if you wanna learn more about it or purchase something, they're all down below. Same thing with 3M's Clash of the Grinders. Last year we were a big part of it. This year we're gonna be even a bigger part of it, and they're giving away so much money and cash prizes, welding machines, everyone who comes to the event to compete, and those signups are down in the description below. We'll see you guys on the next weld. Unfortunately, I need to square up this hole a little bit before I go try to put a bevel on it. Again, apologies for not having that arch shot, but stuff happens when you party naked, you know? Or excuse me, stuff happens whenever you shoot alone in your shot by yourself. Didn't know the camera died. I need like an alarm system or something. It was like, stop doing it, it's not happening, you're not getting it. Anyway, my dog getting attacked by a mockingbird. Wait for it, there it is.